It happened! Elon Musk and NASA finally reveal new Lightspeed engine. Space has always seemed to be out of reach. With the recent collaboration of Elon Musk and NASA, it seems like we are closer to space than ever before. The new Lightspeed engine has gotten the attention of the world. So what is the technology behind its engine? When will it launch? On April 2nd, Elon Musk and NASA reportedly debuted a new rocket called the Lightspeed engine, a revolutionary design that defies physics and fundamentally alters the rules of existing space travel by enabling humanity to reach Mars in a matter of weeks as compared to months. A new spacecraft is currently testing the engine. Let's discuss the features of the engine and rocket. Tech advances are what Musk is renowned for. With PayPal, he set the bar for online payments. With Tesla, he revolutionized the electric vehicle business. And with SpaceX, he essentially founded the private space sector. Even NASA could not resist shaking his hand after he debuted his new engine. Let's look at Musk's ultimate goal, colonizing Mars. The Starship, a powerful spacecraft that Elon Musk's business is creating, will be used to settle Mars. Elon Musk must design the ship that will transport both freight and people to this red planet, as that is the most crucial component. Traveling between planets wouldn't be a problem if there was only a little distance between them. Although there is a great distance between Earth and Mars, the closest distance is roughly 34 million miles. The Starship will, in Musk's opinion, go far more quickly than the James Webb, but passengers can still expect a 5-month journey, which is not suitable for the length of people for a variety of reasons. Musk wants to make space travel a reality by building a Lightspeed engine that can accelerate to 186,000 miles per second and transport people to Mars in about 70 days. The new Speedlight engine, also known as the helical engine, is extremely quick. It can go 240,000 miles to the moon at an astounding speed of 300 million meters per second. The colonists sent by Elon Musk will get to Mars in 12.5 minutes. In roughly 4 hours, you will arrive on Neptune, which is 2.7 billion kilometers away. This small engine would need to be quick and use a lot of fuel, but it will also need to be able to store enough energy to run for years. The concept behind the engine. An engine that transforms centrifugal force into linear motion was invented by a U.S. inventor called Robert Cook in the late 1970s. They were first proposed as a drive in the early 2000s by a British inventor by the name of Roger Sawyer, who claimed to be able to generate thrust from trapped microwaves. According to NASA engineer David Burns, who has been working on this issue in his spare time, an engine concept has been developed that can theoretically accelerate to 99% of the speed of light. That is accurate, but there's more. This engine could accomplish this without even using propellant. He refers to it as the helix engine. By accelerating a loop of ions to almost light speed and then modifying their velocity and mass by the laws of relativity, the helical engine takes advantage of a weakness in Einstein's Indian theory to go forward without having to fire anything out behind it. To grasp the concept, consider placing a ring inside of a box that bounces in one direction and recoils in the opposite. As the ring reaches the end of the box and springs backward, the box's recoil direction also changes. Normal conditions would lead the box to squirm back and forth, but since the ring and the box are both moving at the speed of light, by the time the ring reaches the end of the box, its mass would have grown due to quicker movement while bouncing back, giving rise to forwarding momentum. Even though this engine wouldn't need propellant, it would still require the use of an accelerator and ion particles. The spacecraft is designed to enter space without any fuel by making use of the mass-shifting phenomenon at close to light speed. Working on the engine. The engine uses an acceleration device in the form of a helix that produces a net push in a certain direction. The ions in the loop would then undergo a slight relative speed acceleration in the engine before having their velocities changed to alter and change their mass. By shifting the ions back and forth in the direction of the motion, the engine generates thrust. The only moving parts in the engine would be the ions traveling in a vacuum line while being contained by magnetic and electric fields. It must be powered by solar energy or another external energy source, such as a satellite or another spacecraft, or even ground station that receives radio signals. Experiments are still in progress to make such a system that can provide energy in space. Which spaceship uses the engine? The Raptor, a massive, super heavy launch vehicle and booster rocket combination, will be equipped with this engine. It will have the capacity to launch 170 tons into low Earth orbit. To put that into perspective, the only operational Falcon Heavy lift rocket from SpaceX has a lifting capacity of 54 metric tons. This means that the Falcon 9 launch vehicle's 3 first-stage Merlin engines could potentially be replaced by a single Raptor engine. The Raptor differs from other conventional rockets in that it uses liquid methane rather than kerosene, which has been used since the 1950s to power its engine. Compared to conventional rocket fuel, methane is cleaner to generate and easier to handle, but it is also quite dangerous. Conventional rocket engines cannot use methane as a propellant because they cannot withstand the high pressure and heat required to liquefy it. However, SpaceX is prepared to use Raptor to figure out how to harness the power. The experimental engine, which uses liquid oxygen (LOX) as an oxidizer and methane as fuel, produces 420,000 pounds of thrust, exceeding the existing U.S. Controversy over Lightspeed engines. Some have asserted that this new engine's very design may violate the laws of physics. Others, however, contend that the engine concept is just good on paper and that it would be difficult to construct an engine that is both big enough and strong enough to function. A fundamental law of physics is the idea of conservation of momentum, which states that a system's momentum will not change in the absence of any physical forces. In light of the foregoing, a helical engine shouldn't be practical, but there is always the special relativity exception. The helical engine, in contrast to other devices, makes use of special relativity, which asserts that when an object approaches the speed of light, it gains mass. An electromagnetic drive (EM) drive has successfully passed tests at EagleWorks laboratories under conditions resembling those in deep space. Additionally, they assert that the results of these tests support a thrust-to-power ratio of 1:4, which is higher than any of their calculations for such a device projected and may present fresh opportunities for deep space travel. Other scientists have not yet verified the findings. Elon Musk's successful experiment. Elon Musk's business, SpaceX, claims to have developed and successfully tested a propulsion system that defies physics. With the help of electrically charged gas, the rocket propulsion system can travel at speeds of up to 65 kilometers or over 135,000 miles per hour. The engine is constructed from cold gas thrusters and extremely light carbon fiber fuel tanks. It does not emit any byproducts into orbit because it does not use any kind of propellant. Instead, the engine accelerates superheated plasma with magnetic fields to produce thrust, which also means that combustion emissions are not released. Although they are referred to as electric thrusters, these engines operate very differently from those found in SpaceX's Falcon 9 rockets. These thrusters generate thrust by accelerating pressurized gas, whereas electric thrusters generate a charged plasma that produces ions to move a vessel. According to reports, SpaceX's electric engine, which might power manned flights to Mars and beyond, is more strong than traditional gridded ion thrusters. Because it uses less propellant, which can be expensive to launch into orbit, the distance that cargo must travel to reach space could be shortened. Before the technology is ready for spaceflight, more testing and development are required. According to NASA scientists, it has the potential and has been submitted for peer assessment. This ends our video for today. Tell us what you think about the engine. Is it possible to travel at the speed of light or not? Give your reviews in the comments. Like, share, and subscribe to the channel to find out more. See you in the next video.